What if Earth stopped being home? Overnight? Not because humanity disappeared, but because Earth became impossible to live on. The oceans rise. Heat waves don't end. Food becomes unstable. And the air in some cities feels like you're breathing smoke. Now imagine the unthinkable happens. Humanity is forced to leave Earth, not for adventure, not for science, but for survival. The question is simple. Where do we go? The first answer people always give is Mars. It's close. It's famous, and it feels like our backup plan. But Mars is not a second Earth. Mars will freeze you, suffocate you, slowly cook your DNA with cosmic radiation, and crush your settler dreams under a dusty red sky. It's not a new beginning. It's a slow-motion death trap. So if Mars is the easy option, and it's still nearly impossible, then surely there must be something better out there, somewhere in the Milky Way. There are planets orbiting other stars, exoplanets, worlds that might have water, maybe atmosphere, maybe temperatures that don't kill you in seconds. Today, we're going to look at 6 of the most promising exoplanets and ask the real question, which one could become Earth too? And we start with the closest one. Meet Proxima Centauri b. It's only 4.24 light-years away. That sounds close, until you remember what a light-year really means. A light-year is the distance light travels in 1 year. So if you had a spaceship that could travel at light speed, you'd reach Proxima b in just over 4 years. But let's be honest, we don't have that technology, not even close. The fastest object humanity has ever built is NASA's Parker Solar Probe, moving around 700,000 kilometers per hour. And even if you could somehow ride that probe, it would still take you about 6,500 years. That's not a mission, that's a myth. So the only way Proxima b becomes a real option is if humanity builds technology so advanced that it sounds like magic today. Like ultra-efficient fusion engines, generation ships, cryogenic sleep pods, artificial ecosystems inside spacecraft, AI that can run a civilization while humans sleep. So let's say, somehow, it happens. You wake up, and you finally arrive. The first thing you notice is the sun. It's not bright like Earth's sun. It's dim, red, and disturbing. This star is Proxima Centauri, a red dwarf star, smaller than our sun, and far, far dimmer. The sky feels wrong, not because it's scary, but because it's unfamiliar. Like nature is speaking a language you don't understand. But the real problem is this. Proxima Centauri b is tidally locked. That means one side of the planet always faces the star forever, and the other side never sees sunlight. So you get 2 extreme worlds on one planet. Dayside, hot, brutal, burning, anywhere from 40 degrees Celsius to 100 degrees Celsius. Nightside, frozen death, down to minus 150 degrees Celsius. So where do you land? In the only place that doesn't immediately kill you? The Terminator Zone. The thin line between eternal day and endless night. A ribbon of survival. You land in the Terminator Zone. Your thermometer reads around 15 degrees Celsius. Perfect. You step out onto the surface, and the ground crunches under your boots. Dust blows across the rocks. Wind hums through alien valleys. For a moment, it feels like you did it, like you found a new home. Then your life support system reminds you, you are still standing on a planet that wants you dead, because the atmosphere here is unbreathable. Too much carbon dioxide, almost no oxygen. If you take your helmet off, you don't get a warning. You die. So even though the temperature feels friendly, the air is a lie. Proxima b looks survivable, but it isn't. Not yet. Now you have a new goal. Build shelter. Fast. And not just a normal shelter. Because red dwarf stars are violent. They can fire off massive bursts of X-rays, ultraviolet radiation, solar flares, particle storms. And on Earth, our atmosphere and magnetic field protect us. Here, you get hit directly. So your first week isn't about exploration. It's about survival.
Solar
engineering.
panels are
You
unreliable.
dig, you build.
Proxima Centauri
your
is
habitat
dim,
under soil,
and flare activity can destroy electronics.
Dirt, so you use wind turbines.
For power,
the air here moves enough to generate energy. But power isn't the only thing you need. You need a second structure, a radiation bunker. If your sensors detect a flare, you don't watch it, you run underground. Because outside, a single radiation storm could damage your cells for life. By the end of the first month, you're no longer just surviving, you're building a future. A second hub, stronger walls, better seals, a real routine. And then comes the most important thing, a greenhouse. Inside it, you grow potatoes, algae, kale, whatever survives. It's not a meal, it's oxygen and life. Because on alien worlds, plants are not decoration, they are the beginning of civilization. Soon, you venture further out. You explore valleys and cliffs. You name the features. Because naming something is the first human act of ownership. Twilight Spires, Echo Crater, Flatline Ridge. Your outpost is ugly, dusty, and constantly threatened by solar flares. But it works. You made it. By the end of year 1, you've built living quarters, labs, power grid, radiation shelter, greenhouse. Your menu is still tragic, but you're alive. You live in the ribbon of twilight, between fire and ice. One step too far into the dayside, you cook. One step too far into the night side, you freeze. So you stay exactly where survival is possible. Centuries pass. The settlement grows. Technology evolves. Oxygen generators begin converting carbon dioxide into breathable air. Slowly, the planet becomes less hostile, at least inside controlled zones. But the star never becomes peaceful. Solar flares still hit. Radiation still leaks into your world. And even with bunkers, the damage builds up. Future generations suffer. Higher mutation rates, higher health risks, shorter lifespans. So yes, Proxima B is a success, but it's not a paradise. It's survival. Forever. So while Proxima B might work, it's still living on the edge of death. Which means we need to explore other worlds. Worlds that could be safer. Worlds that could be closer to Earth. Next, now we travel to a different neighborhood in space. Meet TRAPPIST-1e. It's about 40 light-years away, which already tells you something important. If you're coming here, you're not coming back. But TRAPPIST-1e is special, because it's one of the most Earth-like exoplanets ever found. It's only slightly smaller than Earth, and it sits in the so-called Goldilocks zone. Not too hot, not too cold, where liquid water might exist. And if there's one ingredient life needs, it's water. You touch down, and instantly, the world feels different. The sun hangs low in the sky like a permanent sunset. Not because it's romantic, but because the star is tiny. TRAPPIST-1 is an ultra-cool red dwarf star, barely 9% the mass of our sun, and hundreds of times fainter. So the light is dim, soft, almost haunted. It feels like living inside the last minutes of a day. That never ends. Your body feels strange, almost graceful. Gravity here is about 90% of Earth's gravity. Not enough to make you float, but enough to make movement feel easier. You take a step, and it feels like your body is slightly less heavy. For the first time since leaving Earth, you feel like you can breathe again. Not literally, but emotionally. But just like Proxima B, TRAPPIST-1e is likely tidally locked. One side is always day. The other side is always night. The day side could be too hot. The night side could be too cold. So you already know the strategy. Land in the Terminator zone. That thin region between fire and ice. Except this time, it's even colder. Temperature might be just above 0 degrees Celsius. Brisk, but survivable. You can work. You can build. You can live. If everything goes right, now comes the moment every settler dreams about. You step outside. You're standing on alien soil, and you ask the forbidden question, can I take off my helmet? Because if the air is breathable, this becomes the closest thing to Earth 2 we've ever seen. But you don't take risks, not after traveling 40 light-years. So you keep the helmet on, and start testing. You scan the surface, and you find it. water, maybe ice, maybe lakes, maybe underground reservoirs. But water exists here, and that changes everything. Because with water, you can grow food, create oxygen, build a real future. So your settlement begins near a water source. You deploy extraction systems, filters, purification, storage. Because on alien planets, clean water is worth more than gold. Next comes the greenhouse module. Plants are the first step toward turning a base into a civilization. But there's a problem. TRAPPIST-1's light is dim. Your plants won't grow properly. So you bring artificial sunlight, LED grow lights, and yes, kale is still on the menu. Because no matter where humans go, kale somehow survives longer than we do. But don't celebrate too early. Because red dwarf stars are dangerous. TRAPPIST-1 still produces violent flares, radiation storms, UV bursts. So once again, you build bunkers, you bury habitat walls under soil, and you live with one rule. If the alarm triggers, you run underground. Because out here, radiation doesn't just harm you, it rewrites you. After 1 month, something incredible happens. You stop feeling like a visitor. You start feeling like a resident. The habitat is stable. The power system is strong. Water filtration works. Greenhouse production starts. And after enough testing, you find the biggest surprise of all. The environment is safe. The air isn't killing you. The soil isn't poisoning you. There are no obvious toxins. No instant death chemistry. This is rare. And it's huge. So slowly, some settlers begin taking off their helmets. For short periods. Not because it's 100% safe, but because hope is addictive. A century passes. The population grows. Hundreds of people. Then thousands. More ships arrive. More habitats expand. Settlements spread carefully across the safer zones. TRAPPIST-1e becomes the most Earth-like human outpost ever built. But there's still one curse. Solar flares. If the planet ever loses protection, this could all collapse. So it's not a paradise. It's a fragile miracle. And it survives only because humans never stop maintaining it. TRAPPIST-1e is a strong contender. But we're still searching for something better, something bigger, something stranger. Next, a world that might be covered in oceans, or might not even have solid ground. Meet K2-18b. K2-18b is one of the most exciting exoplanets ever discovered. It's about 120 light-years away. It orbits in the habitable zone of a red dwarf star. And it's not Earth-sized. It's bigger, a lot bigger, about 2.6 times the size of Earth, and 8.6 times the mass. So the gravity would be heavier. Your body would feel pulled down. Every step would cost more energy. This isn't a planet you run on. It's a planet you endure. The dream version of K2-18 billions is incredible. A super Earth, covered in oceans. A real water world. A planet where floating cities could exist. A world where life might already be swimming below the surface. But then comes the nightmare version. A mini Neptune. Meaning, no solid ground. Just crushing pressure. And thick gases that would destroy humans instantly. Either way, K2-18b is not a normal colony. It's a gamble. K2-18b likely has a thick, hydrogen-rich atmosphere. Great for trapping heat. Terrible for breathing. You're not walking outside. You're not taking off your helmet. If you open your habitat door, you don't explore. You die. So, how do you settle here? You don't build a city on land. You build it where survival is possible. You build a floating habitat, not floating on the ocean, floating above the clouds. A city hovering in the sky, where pressure might be survivable, where temperatures might be stable, where storms are deadly, but predictable. To survive here you need extreme storm resistance, thick radiation shielding, stable power sources, atmospheric processing, constant repairs. It's not easy, but it's possible, and humans love one thing: doing impossible things, just to prove we can. Now here's the detail that makes this planet legendary. Scientists detected methane, carbon dioxide, and possibly dimethyl sulfide, a chemical that on Earth is often produced by life. That doesn't confirm aliens, but it whispers something dangerous. What if life already exists here? And if life exists, we're not colonizing an empty planet. We're stepping into someone else's ocean. That changes everything. K2-18b might be a water paradise, or a gas nightmare, or even a living planet. But we still need something stable, something simple, something closer to Earth-like size. That takes us to Kepler 186f. Kepler 186f made history because it was one of the first Earth-sized exoplanets discovered inside the habitable zone of its star. When it was announced, people started calling it a future Earth 2. But with Kepler 186f, the good news begins fast and ends even faster. Kepler 186f orbits a cool red dwarf star, and it sits on the outer edge of the habitable zone, meaning it receives only about 32% of the sunlight Earth receives. So unless this planet has a thick heat-trapping atmosphere, it could be frozen, a world of ice, a planet where water exists, but locked away. And if it's frozen, your colony isn't building a civilization, it's building a freezer survival station. Solar power won't cut it here. The star is too faint, so you'd need nuclear power, heavy generators, long-term reactors, constant maintenance, because without energy, your habitat dies. And on this world, heat equals life. And then comes the worst part. Kepler 186f is about 500 light-years away. That means no rescue ships, no supply runs, no backup plan. If something goes wrong, it's not a mission failure, it's extinction. And, to make it worse, it's the only habitable zone planet in that system. So if it doesn't work, you don't move to the next planet. You freeze and end. Now we go even farther. Much farther. Meet Kepler 62f. It's about 1,200 light-years away. At this distance, Earth isn't your home anymore. It's a memory. If you travel here, you're not moving planets. You're leaving your species behind and restarting it somewhere else. And whatever happens on Kepler 62f happens alone. Kepler-62f orbits a star called Kepler-62, a K-type orange dwarf. Now that might not sound exciting, but it's actually good news. Orange dwarfs are often calmer than red dwarfs, less violent flaring, more stable light, a more predictable environment. And when you're trying to build a civilization, stability is everything. Kepler-62f is a super-Earth, about 1.4 times the size of Earth. That means gravity might be stronger. Not crushing, but noticeable. Walking feels heavier. Carrying equipment feels harder. And the biggest issue? This planet orbits farther out. It receives less warmth and light. So without help, it may be frozen. Large sections could be permanently covered in ice. A world that looks peaceful, but is basically a deep space freezer. But here's why Kepler-62f is still a serious candidate. Because it might be terraformable. If you give it the right atmosphere, everything changes. Imagine an atmosphere 3 to 5 times thicker than Earth's. Rich in carbon dioxide, that thick blanket could trap enough heat to turn parts of the planet temperate. Not everywhere, but enough for survival zones to exist. And that's what humans need. Not perfection, just a stable foothold. If you're building here, you choose the warmest possible region, near the equator, near the day side, a place where the sunlight is strongest. And your colony begins the same way all colonies begin. Heated habitats, radiation shielding, atmosphere processors, greenhouses, nuclear reactors, strict survival routines. But unlike Kepler 186f, this world has one advantage. It's not hopeless by design, it just needs help. And humans are very good at forcing planets to cooperate. Kepler-62f is not comfortable, but it's buildable. A super-Earth with long-term potential. A place where a civilization could evolve, not just survive. You're still buried under heavy walls, still recycling water, still rationing food. But for the first time, you don't feel like you're living in a death trap. You feel like you're building an actual future. Kepler-62f is a frozen world that could be fixed. But maybe there's something better, something closer, and more stable. That takes us to a system called TOI 700, and the planet everyone talks about is TOI-700d. TOI 700 is a cool, quiet red dwarf star, and that matters, because most red dwarfs are chaotic. They flare. They blast radiation. They punish anything that tries to live near them. But TOI 700 is different. It's calmer. Not perfect, but calmer. And for settlers, this feels like a gift. TOI 700d is about 20% larger than Earth. Gravity slightly stronger. Nothing insane. And it receives about 86% of the sunlight Earth receives. That's almost perfect. Not too hot, not too cold. This is the kind of planet that makes scientists say, wait, are we actually looking at Earth too? But there's a catch. TOI 700d is also likely tidally locked. One side is eternal day. The other side is eternal night. So once again, you aim for the Terminator zone, the Twilight Ribbon. The only region where humans can live safely without boiling or freezing. So the strategy repeats, build where survival is possible. Then expand slowly. But here's what makes TOI 700d scary. We don't actually know what the atmosphere is made of. It could be oxygen-rich, breathable, friendly, or it could be carbon dioxide soup, or toxic chemistry, or nothing at all. So you don't remove the helmet. Not at first. Because settlers don't die for curiosity, they die for mistakes. And mistakes are expensive. When you're 100 light years from home, and even if the air is safe, there's another threat. Weather? A planet with permanent day on one side and permanent night on the other creates insane pressure differences. That could mean non-stop wind systems, possibly extreme winds screaming across the planet, day and night. Imagine building a city where the atmosphere never rests, where wind is always hunting for weak points, where every wall must survive storms forever. TOI 700d might be habitable, but it could be loud, violent, and exhausting. And then there's water. We still haven't confirmed surface water here. If water isn't available, then you're not building civilization. You're building a life support prison. So TOI 700d becomes a question mark. Maybe it's the best option, or maybe it's another beautiful trap. So, after all that, which planet is the best chance for Earth 2? Let's be honest, none of them are perfect. But some are clearly better than others. Earth-sized, but too cold, too far, too risky. You don't colonize this. You survive it. Closest, but violent star, unbreathable air, radiation nightmare. Survivable, but brutal forever. Terraformable and exciting, but too uncertain. Ocean paradise, or gas giant nightmare, or alien life complication, great on paper. Stable star, right sunlight, but unknown atmosphere plus possible extreme winds. A high potential gamble. Earth-like size, possible water, breathable conditions, but flare risk remains. Still, this is one of the strongest candidates, because it might be the best long-term world to terraform. Stable orange dwarf star, super Earth size, and the possibility to trap heat with a thicker atmosphere. Kepler 62f doesn't look like Earth today, but it could become Earth-like tomorrow. But here's the real truth. Even if we found a perfect Earth 2.0, it would take centuries to build it. Generations would live inside metal walls, under radiation shelters, breathing artificial air, eating greenhouse food, and surviving one system failure at a time. Exoplanets are not escape plans. They're hard mode. So maybe the real lesson is this. Before we dream of making alien planets habitable, we should protect the one planet that already is. Because Earth is not replaceable. It's priceless. If you enjoyed this documentary-style future timeline, subscribe to Daily Factify. And comment this. Which planet would you choose? TRAPPIST-1e or Kepler-62f? Because the next episode